So I'm Maeda from Tohoku University, Japan. So I lead a working group too from Japan side, and the Rafikul-san, Dr. Rafikul is the leader from Bangladesh side. So I would like to briefly talk about the framework of our seismic evaluation guidelines. So the I think the most part, very key issues already Rafikul are already introduced, but the as you may see, in Japan we have already developed the seismic evaluation manual, and this manual is applied to the existing building structures in Japan, and the Bangladesh side CNCRP manual is developed. So and some basic concept is common between these two manuals. So as already the Rafikul-san introduced. So this guideline, so to evaluate seismic capacity of existing building structure is the IS index. This index is used. And this index is the structure of this index consists of 4 components. The first, the strength index and ductility index. And S, D, and T, it's some kind of penalty factor. So if there is the structural irregularity or deterioration due to aging or something like that, the capacity will be reduced. But there is no problem. So this is no penalty. So the fundamental capacity of building structure is strength and ductility, deformation capacity. So the product of C index and F index is kind of energy dissipation of building structure against the seismic shaking. So this index, how to say, the very unique characteristics of IS index is to evaluate energy dissipation capacity. So sometimes very strong, but very ductility is not so good. But some structure is low strength, but very large deformation capacity. So that we can evaluate including both strength and deformation capacity in this IS index. That is the basic concept. So as maybe detail already some already explained in the method for the evaluation of IS index. So today it's very good opportunity for me to introduce the background of IS index for the application to the existing building structures just after the earthquake. So as already Rafikul-san introduced, the judging criteria for the IS index is 0.6. This is to judge if the IS index is larger than 0.6 in Japan, that we consider the seismic capacity is enough against major earthquakes. And this kind of judging criteria is not only theoretical investigation, just application to the damaging earthquake, and we learned the lessons from this damage due to earthquake. Today I would like to show two examples to the application to the existing building structures in Japan. And this is just the case in Japan. So we are not thinking to this judging criteria is directly applied to the Bangladesh because many building type or seismicity or many things is different. So maybe we need to discuss more how much IS index is good for the judging criteria in Bangladesh in the application. But anyway, so maybe how we decide and confirm the IS index of 0.6 is okay. That is our Japanese experience. So please see this. This figure is showing the damage ratio due to the 1995 Kobe earthquake and for the school building. So I mean, most of the building will be 3 stories or 4 stories, reinforced concrete structures. And this is the damage ratio of the building. And we classified the building into 3 groups based on the seismic code revision. So this is we in Japan, we revised the seismic design code based on the lessons from the earthquake. In first major revision was done in 1971, and second one is done in 1981. And the tendency or damage ratio is very different based on the seismic code. This is the first generation, and the almost 10% building suffered the very severe damage or collapsed, and 30% of the building was moderately damaged. This means the moderate damage means it is possible to repair, but somehow the very heavy repair is necessary. And you can see the very, so by this seismic code revision, so the collapse or severe damage was very reduced by this seismic code revision. And due to after the second seismic code revision, so no severe damage or collapse, and only 10% of the building was suffered moderate damage. So I mean the 90% of building was escaped some severe damage, even against the 1995 Kobe earthquake. That is the one lessons and some kind of success of the seismic code revision. And this graph is same school building, and the vertical axis is the IS index, seismic capacity. And this line, 0.6, is the judging criteria. And this line is construction years, so the 1971 and 1972. So here is first generation and second generation, third generation. So again, the tendency is very clear. So before 1971, most of the building, the IS index is less than 0.6. And after 81, but the data is very few, but all the building, the IS index is larger than 0.6. So this mark is indicating to damage level, collapse and severe or moderate damage. So most of the severely damage or collapse or moderate damage is less than 0.6. So based on such kind of analysis, so we decided to confirm the IS index is work well to judge the seismic capacity of building structures. So, and I think fortunately in Bangladesh, you don't have this kind of severe earthquakes. So that is why it's a little bit difficult to do the same kind of work in the Bangladesh building, but maybe you can collect some data from not only Bangladesh, from outside your country. So then you can discuss or check which level is suitable for the judging criteria for seismic evaluation. And then the next I'd like to talk about the basic idea of seismic evaluation or rehabilitation flowcharts in our SATREPS guideline. And of course, our guideline is worked together with CNCRP manual. And so we developed, maybe today we do not have enough time, and I guess we already introduced this one, the visual rating method. So very rapid evaluation or classification of seismic capacity of building structure. And in seismic evaluation stage, we will evaluate the seismic, we are thinking to prepare the two levels, first level evaluation and second level evaluation. This is basically based on the very simple calculation method. But anyway, in our seismic evaluation manual, first we need to consider the structural irregularity, and one of most big difference between Japan and Bangladesh is masonry infill wall. So in Japan, the masonry infill wall is not popular. So in seismic evaluation, masonry infill wall is not taken into account, not considered. But in Bangladesh, the masonry infill wall is very popular. So that is why we developed some calculation method for the masonry infill. So this figure is already explained from the Lapikuru-san. And at the beginning of our project, we discussed, and the Bangladesh side showed some typical problem to be considered in seismic evaluation. And based on discussion on these kind of characteristics, we pick up the things to be considered in our SATREPS-TSUIB guideline. So that today, from now, after my presentation, 5 items will be presented. So mainly, that we focus to these 5 items for the seismic evaluation, in addition to the CNCRP manual. So first one is masonry infill wall. And second one, it's sometimes in your country, so the concrete strength is low. So in such cases, the failure mechanism or deformation capacity or strength is different from the normal concrete structure area. And another very typical structure is flat plate structures. So in Japan, the frame structure is very popular, but in Bangladesh, flat plate structure is very popular. So that's why this is. And beam column joint problem will be some kind of anchorage bar, reinforcing bar anchorage problem. And the last item is how to evaluate the concrete strength. So especially for the low strength concrete. Still, these 5 items is included. And this is team formation to development of research and development of manual. So non-destructive tests is Tohoku University and the cycloamine from Buet is work for this topic. And low strength concrete, University of Tokyo, Professor Nakano and cycloamine from Bueto. And masonry field wall is work with my Tohoku University and PWD and Asanura University. And beam column joint, the Professor Sanada from Osaka University and Professor Cycloamine from Buet. And flat plate structure is again the Professor Sanada and the Professor Takahashi from Daido University and the Professor Anam from UAP. That is the team formation of the development of seismic evaluation manual. And this is the contents. So this, after following the general part, these 5 items will be appear in this guideline. Okay, so this is a formation, and so that's all by just introduction of our project. So thank you very much for your attention. Onek Donobat. Thank you very much.